Welcome to Module 1. This first module is relatively short, but it includes a lot of very important foundational vocabulary that you will use the rest of the course. And in this first video, I'm going to talk about 11 of those vocab terms. You can see that the very first one here is statistics, and you saw this in the intro video, that statistics is the study of collecting, describing, and drawing conclusions from data. And typically, whenever we are drawing conclusions from data, we are drawing those conclusions based upon a sample, which is a subset of a larger population that we're trying to study. Think about an election, for instance. Many times you're interested in the proportion of people who would vote for a candidate going into an election. And so a polling agency might go out and take a sample of voters, and from that sample, try to construct it in a way where it is representative of what's happening for a population. And that's, in a nutshell, what statistics is about. It's using samples to speak for populations. And the best type of sample that you can work with in here, the gold standard in the opinion of a lot of statisticians, is something called a simple random sample. And a simple random sample is defined as follows. And at first it might seem a little bit strange, but I'm going to walk you through some examples that will hopefully help it make sense. This says a simple random sample of size n is a sample chosen by a method in which each collection of n population items is equally likely to comprise the sample, just as in a lottery. Okay, so what that's saying is there is this population that's out there, and there's all kinds of people or subjects in a population or items in a population, and every single person or subject or item in that population has an equally likely chance of being chosen as part of a sample. And so if every person or subject or item does not have that equally likely chance to be part of the sample, then we would not describe that as a simple random sample process. Let's take a look at some of these examples here. So example 1, I said WCC employees are surveyed by assigning a random number to each, and then certain numbers are called for their opinion. And so if random numbers are given to all WCC employees, and so that's our population, and maybe the administration is surveying all WCC employees and says, okay, we're just going to take a sample of so many employees. But if they're doing this in this random way, then every employee would have an equally likely chance of being called for their opinion. And so I would say yes, this is an example of a simple random sample. Example 2, we have a class of 30. And let's say that I select the students sitting in the front row. So my population is pretty small here. It's just my class. But I say, you know what, just to make the sampling process easier, I'm just going to pick the students in the front row. Is that a simple random process? And it is not a simple random process. And the reason is every single student is not given an equally likely chance of being chosen as part of the sample. And remember, that's the definition of a simple random process. Every person or subject or item in that population has an equally likely chance of being chosen. That is not happening here. So we would say no, this is not a simple random sample. This is actually what we'll see in a little bit that I call a sample of convenience. And like I said, you'll see that in just a little bit. Example 3, we've got a lottery example. So let's say that we go and choose some numbers for the lottery, and there's some of these common lotteries where they say, okay, you pick 6 numbers, and maybe you can win this big prize of millions of dollars. And so let's say I went in and I chose the numbers 1, 2, 3, 4, 5, and 6. My question is, are your odds of winning any worse with 1, 2, 3, 4, 5, and 6 than they are with spreading your numbers out, like 10, 15, 25, 33, 45, 52. And the reality of it is, no, the winning numbers are actually chosen through a simple random sampling process. Basically, all of the numbers in the population of numbers that are chosen in a lottery, all of the numbers have an equally likely chance of being part of the sample. And that means every combination of 6 numbers, whether it be 1, 2, 3, 4, 5, and 6, or 10, 15, 25, 33, 45, and 52, any combination of 6 numbers has the same chance of winning. We have an equally likely chance of getting this as we do of getting this right here. And because of that, yes, your odds of winning are actually poor with a lot of these things, but this is a classic example of another simple random sample. Lotteries are simple random samples. Example 4, a pollster wants to estimate the Democrats in a town. They go to a local mall to poll 100 people. Is that a simple random process? Does every single person living in the town have an equally likely chance of being chosen as part of the sample? No, there's no way that all of the people can be in that mall at the same time. And even if they were, would everybody in the mall necessarily have an equally likely chance of being part of the sample? I don't think so. So this would be another case where we would say, no, this is not a simple random sample. So just to reiterate one more time, a simple random sample is a sample in which each person in the population must have the same chance of being part of the sample. And so what I'm going to do is I'm going to simulate a sampling process right now. And what I'm going to do is I'm going to pretend that I've collected data on our class. And let's say that the class has 30 people in it. So I've numbered these students in the class from 1 to 30. And all of the numbers that you see here are the number of keys on everybody that's in a particular class. And so what I'm going to do is I'm going to draw a sample of size 5, and I'm going to compute a sample mean. And the sample mean, which has notation x bar, is going to be what we use to speak for the population mean. And so the population mean is mu. And mu is a Greek variable. You're going to see that a ton throughout this class. Now, typically, when you have a population of size 30, you can find the average of that population with no problem. But I'm just trying to emphasize what this process is like in statistics, when typically you have a large population and you have to take some sample out of that population to speak for the population itself. So what I did is something that you don't have to worry about right now, but I put all of these numbers into the calculator. I said stat edit, and you can see that they're in list 1. This is a menu that you're going to be very comfortable with throughout the class, and it's not something you need to really worry about right now, but you'll be doing a lot with this list menu. Okay, so I'm going to quit out of that right now, and what I'm going to do is I'm going to press Math, go over to Prob, and all the way down to number 5. And I can tell the calculator to randomly select certain people from my class. And I'm going to say the first person is person 1 and the last person is person 30. And I want 5 people randomly selected. So can you see here that each person is going to have an equally likely chance of being chosen? This is kind of like a lottery right here. So I click Paste and I press Enter, and I get the following. I get person 29, person 4, so let's kind of take a look at these. So here's person 29 right here, that's 3. And then we've got person 4, so person 4 is 12. And then we've got person number 1. We can see that person number 1 is 1, or has 1 key. We've got person 17, they have 2 keys. And then the last one is person 26, and person 26 has 3 keys. And so if I wanted to compute an average from those 5 people and get what I'm calling this sample mean, you would add those 5 numbers up and then divide by 5. And you can see that what we get is 15, 16, and then another 5. 21 divided by 5. And 21 divided by 5 is equal to 4.2. Now, one of the things you could probably see is some of these data values are extreme in here. Like you've got 21, we actually got one of the extreme data values, which is interesting. But then a lot of the values that we got were also kind of on the low side. So you can imagine that you could go through this sampling process again and again and maybe even get sample means that are quite a bit different. And that's one of the things that we will talk about later on in this class is there's a ton of variability in a sampling process, and you've got to be really cautious of that variability. But anyways, our sample mean is 4.2. So I guess my question to you is, do you think that this sample mean speaks for the population? Do you think that the population mean is somewhere around 4.2? Well, we can actually determine that because remember, I put the entire population into the calculator. And if I say stat calc, and I say, okay, I've got my data in list 1, I can actually determine my mean. Whoops, there it goes. 4.73 is my true mu. So the true population mean here is 4.73. We came up with an estimate of 4.2. And so look at those numbers right here. You got an x bar of 4.2, you've got a mu of 4.73. You can see that we did a pretty good job with just sampling 5 people of getting an estimate of the population mean. But at the same time, you can imagine that, well, you can see for sure that this isn't a spectacular estimate. It's not spot on, but at the same time, it's within a reasonable range. And maybe you can also see that if we went through this resampling process and we maybe got that number of 21 or some of these other higher values in here, or maybe we got a bunch of low values, you can imagine that we could have actually gotten a result here that would have been way off from the population mean. And like I said, that variability is something that we'll look at later on. But this is what statistics is like, and this is what a random sampling process is like. Okay, a few more vocab terms. We've got samples of convenience. Now, samples of convenience are exactly what you would expect they are. Samples of convenience are when you're sampling, the first 50 people that walk in a door, or, I say, hey, I'm going to sample the, people's attitudes about math, and so I make a post on Facebook or something like that, and I reach out to my Facebook friends. You can imagine that would be a little bit biased because a lot of people that I know are somehow connected to math. So if I'm surveying people about math or something like that, then that's not a reasonable sampling process. Or another sample of convenience is just using my class. And samples of convenience are not usually acceptable, but we have to use them quite often because sometimes there's just a lot of constraints on how we can sample, and there's a lot of expense maybe associated with that. Okay, so now I'm going to talk about stratified sampling and cluster sampling. And stratified sampling is where you take a population, you divide it into groups, and then random samples are taken from each group. For example, if you take people that are attending a university, and we've got freshmen, sophomores, juniors, and seniors, and you say, okay, instead of polling a random sample of people from the university, maybe what I will do is I'm going to ensure that I get so many people from each class. So I'm going to do a random sample of 10 freshmen, a random sample of 10 sophomores, a random sample of 10 juniors, and a random sample of 10 seniors. So overall, it's not classified as a random sample, but you're breaking the population up into groups, and then you are doing a simple random sample from within each group. And so this kind of gets contrasted with something known as cluster sampling. And cluster sampling is where instead of sampling some people from all groups like we did here, you're sampling all people from some groups. Let me actually write this down. So stratified, I'm going to go back and say stratified is you sample some from all groups, whereas cluster, you sample all from some groups. And so cluster sampling would be, let's say WCC is our population, we're surveying WCC students, and we say we're going to go in and select 10 classes, and maybe we do this randomly, but we're going to survey all the students in 10 classes and use those results to speak for our population of WCC students. So I think a really good way to think about this is exactly as I just wrote down, but it's also good to visualize. And so I'll show you in a picture here what stratified would look like, and then in another picture what cluster sampling would look like. So let's say I'm taking my population and I'm dividing it into groups, and I've got several groups here. in my population. Okay. And then we'll do the same thing over here. Several groups. But with stratified, what I'm going to do is I'm going to sample some people from all groups, whereas cluster would be I'm sampling all people in some groups. So stratified would look like this, where let's pretend that randomly, these few people got selected in the first group, and then randomly these few people got selected in the second, and then randomly those people got selected in the third, and randomly those people got selected in the last group. So it would be a random process of selection within each group, but notice that some people are being chosen from all groups. Cluster, on the other hand, would be all people from some groups, and so maybe all people from groups 1 and 3 are selected, leaving everybody from groups 2 and 4 out. And so groups as clusters are selected, and those clusters are selected randomly, whereas here a random selection is taken from within each group. So again, stratified sampling some from all groups, cluster sampling all from some groups. Okay, we also have systematic sampling. This is where there's some order to the sampling. I think of like quality engineering, where maybe workers at an assembly plant are testing every 100th part that comes off of the line. And so if they're only looking at every 100th part, there is a method to their testing, and there's a system to their testing process. Another one is voluntary response sampling. We say that this is the worst. You could think comment sections of the newspaper, like who volunteers their responses, when radio shows ask you for something, or who volunteers their responses for hotel ratings or on Rate My Professor and things like that. Typically it's the people who have either a really, really good experience or a really, really bad experience. And I know sometimes, I've seen this with like Rate My Professor, people maybe will rate a professor poorly because they had a bad experience, and maybe that professor has had thousands of students over the years, but there's just a couple of poor ratings that are speaking for what's happening, in that professor's class. So in a case like that, that probably wouldn't be the most reliable information. But when this does become a little bit more reliable is as the number of responses does increase, like as more people are offering their responses on either Rate My Professor or on a hotel rating and things like that. But we do say that voluntary response sampling is kind of the worst. And so in a research context, you typically don't see these types of sampling methods, although sometimes you might, because sometimes you might be handcuffed based upon finances or some other aspect of your experiment. Okay, take a look at these last couple of vocab terms now, statistic and parameter. Statistic is what we are going to use when we classify data that is coming from a sample. And so up above, when we did the example with the keys, remember when we found the sample mean x bar? That is what we would call a statistic. And so at first our statistic was 4.2 for the sample mean. And on the other hand, a parameter is when we have data that's coming from an entire population. And so again, referring to the example with the keys, we found our population mean to be, I think we said it was 4.7 or something like that. And so this population mean is what we would call, or what we would describe as a parameter. And so notice that parameter starts with P, as does population, and then notice that statistic starts with S, as does sample. So throughout much of the subject of statistics, since we're going to be focusing on sampling in order to draw some conclusions about the population, you can imagine we are going to be working with statistics for the most part, because everything's going to be based upon the samples. But our intention is to use those statistics to infer what's happening with the population, to infer what certain parameters might be. And so you'll see this play out a lot throughout this class. Okay, check out the next video now on some additional vocab in Module 1.